Alright, what is up, nerds, programmers, coders, whatever you guys want to refer to yourself as. Today I'm going over Spiral Matrix. I spent like a long time on this one yesterday. I just got stuck in the conundrums of it. It's actually not as hard as it made it out to be. I don't know, maybe I'm just an idiot. But given a matrix of m by n elements, m rows, n columns, return all elements of the matrix in spiral order. So it's just like a snake. So we're going 1 2 3, then 3 6 9 8 7 4 5. So it seems like an easy concept, a little bit harder to implement in code. You have to be really careful. It's very easy to make mistakes. I was making mistakes yesterday. So this one is 1 2 3 4 8 12 10 11 10 9 5 6 7. There's some like edge cases, I guess you'd call it, that you have to check for. So the way I did it is I just did it layer by layer. So this matrix could be, huge. You could have huge layers. So I recursively called it. As you can see here, I have my notes written out. So recursion for bigger matrices. So I just added the top row, and then I added the last column, then the last row, and then the first column. And you have to check or adjust all the indices correctly, and that's how I did it. And I just recursively called it in case there was a bigger matrix, so you can add them all, and we just add that to our new spiral matrix basically. So right here I have our base cases. If matrix is null, or matrix.length equals 0, or matrix 0.length, then we just return a new array. That's actually wrong. I don't know why that was even there. So new array integer. We're just going to return a new array list integer, because that's actually what we have to return. We have to return an array list. And alright. So first thing we want to do is to check to see if we are out of bounds. Actually, I'm going to code this up here. So we're going to want to create our actual list of integers that we're going to return. So I called it spiral new array list. And then I just called this is a function I already wrote. I didn't want this video to take so long, so I did kind of like the pseudo notes for it already. It could have turned into a 20-minute video, and I do not want it to do so. So I'm passing, this is where we're spiraling through it basically. So we're passing in the spiral, which we just created, the matrix, which we provided. We're going to pass in the first row, last row, first column, and last column. So let's do exactly that. And when we're calling it up here, it is not recursive. So let's pass in spiral matrix. And since it's not recursive, we're just passing in the first row, which is 0, and the last row. So that is matrix.length -1. And then the first column, which is 0. And then the last column, which is matrix of 0.length. And that should be it. And then we just have to return spiral at the end of this function. So now let's code our main function. So the first thing we want to check is if we are out of bounds. This will make sense for when we're recursively call, because we're going to let me show you on my iPad. When we're going to shrink the rows and columns by 1 each. So we're going to push this column in 1. So we're going to add 1 to here, and we're going to shrink the rows, add a row from the first row, subtract a row from the last row, and subtract a column from the last column. So it's like shrinking by 1 on each of them. And if they're greater than or equal to, so if the first row is greater than, it's not greater than or equal to, I'm sorry if I said that, is greater than the last row, or the first column is greater than the last column. Then we just want to return. So now we have our top row. We're going to calculate our top row. So for int of I equals 0, or no, int of I. So I have here, we're going through, I'm looking at my iPad, so we are right here right now, so we want to loop through 1, 2, 3, 4. So we're going to go through I equals last column, because there's 3 of them. So we're going to go through the last column, or no, sorry, it's first column. We're setting it equal to the first column, but it has to be while it's less than or equal to the last column. And we're going to increment it, and we're just going to add spiral dot add. So now let's think, what do we want to add? We want to stay in the same row. So matrix of, we want to stay in the same row. So we want to stay in the first row. First row, and then we're incrementing the column. So I. And that's it for that one. And then we're just going to do the last column. So we're at the 4. We have to start here. We want to grab these 3 next. So for int I equals, I believe, first row plus, oh yeah, so we're in the first row plus 1. So right here, first row plus 1, row plus 1, because we already added 4 to it, so we got to go down a row. And while I is less than or equal to last row, because we want to add the 12 here. So that's what the equals is for. I plus plus. And we're adding columns here, so we want the columns to stay the same this time. So we have spiral.add matrix of I, and it's going to be last column, because we're in the last column right there. And here is for weird cases where, like, I think it's, when we have, this is exactly for this, when we have an odd number of rows or columns, they will end up, when we add a row, when we bring this one down, so now it's here, and this one up, they'll equal each other. So we'll have already processed it up here, so we have to check for that. So if first row equals last row, we don't want to, this is to prevent duplicates, or first column equals last column. Then we're just going to return. And so now we have our bottom row. So for int I, so we're at 12. So we're at our last column. So we want to do last column minus 1, because we already added 12. So let's do, now we're going backwards. So last column minus 1. I believe greater than, yeah, because we're going to be decrementing I, so I greater than or equal to first, is it first row? First, let's see, greater than or equal to first column, I'm sorry, it's first column, and we're decrementing I. And now let's add that to our spiral. So spiral.add matrix. So we're adding a row. So we want the row to stay the same. So we're going to do last row since we're in the last row, and we're going to do I, because that's what we're changing. We're changing the column. We're moving along in the columns. And then lastly, we're at the first column. So for int I equals, so now we're at 9, and we need to go up, so we're at last column -1, or last row, I'm sorry, last row -1. And here's a little tricky part, because this is we already added one, so we don't want to add one again. I accidentally added one on my first try, so I had a duplicate. So the way we prevent that is if I is greater than or equal to, greater than or equal to first row, oh, that's not even first row, god damn it, sorry guys, +1. So we're adding the +1 because we already have this one in it, and if we do greater than or equal to first row, we're going to add the first row again, and we're going to be in the wrong position. So yeah, and this is I minus minus as well, because we're going backwards. And now let's add that to our spiral. So matrix, and we're in our first column. So first column, or so this is I, because we're adding the no, wait. Is that right? I in first column. Yeah, okay, that's what I thought. I in first column. Yeah. Sorry, I started to doubt myself for a second. And that should be it. And then this is the recursion for the bigger matrices in case there's lots of layers. So let's just call spiral matrix again. And this will check to see if this is if the matrix has an even number of rows or columns, such as this one down here. So we're going to, here, I'll just code it out so you guys can see. Spiral matrix, and then we're adding first row, but we have to increment it by 1 because we want to, push it down. We already solved that row, so we already added that row, I'm sorry. And then last row is -1, so we're shrinking down the layers. And then first column +1, and last column -1. And so when we have an even number of rows or columns, because we're adding one and subtracting one, they're going to equal each other. So that's what this is checking for. If they're the same, then we've already processed them all, so that's why it returns. That's what that's for. So let's run this code. Hopefully it works on my first try. And no, of course it does not. What is it asking for? Oh, it's a semicolon instead of a period or a comma. Of course not. Notes, I think it was a LeetCode error, but one thing I did forget is I did forget to decrement the column length -1. So that was one little mistake, but yeah, now it works. So let's submit this. And 100%, so awesome. So the run times O of n and O of n space complexity as well. If you guys have any questions, please don't hesitate to contact me. And if you guys want me to solve any problems, let me know. And any criticisms on the videos would greatly be appreciated. And I'll see you guys in the next video. Thanks for watching.